In this lesson, we're going to be talking about the concept of slope. Slope is also called the rate of change. It's represented using the variable m. Now let's go ahead and talk about what it means visually before we start calculating it mathematically. So if you look at my little biker here, my biker is biking on a slope. And you might be thinking, well, skiers ski down a ski slope. It's the same concept. It's basically a surface that has a gradient towards it, or an incline to it. So you can see that the first picture here is the biker is going uphill. Now, when we read this, we always read like we're reading a book, and we read from left to right. So in this case, the biker is going uphill from left to right, which is going to create a positive slope. The second one, you can see that the biker is going downhill from left to right, therefore he's going down a negative slope. The third one, you can see that the biker is just biking on a flat surface, and this is called a zero slope when you have this flat surface. The best way that I like to remember it is if you've ever walked or ran on a treadmill, there's a little button on the treadmill that says incline, and if you press that button, it'll take the slope and it'll increase it so that you're walking or you're running more uphill. And then, of course, you can take it down so that you're walking on that flat surface. But the treadmill always begins at zero. It's always a flat surface. So that's our indication that this line is going to be called a zero slope. And then you have the last type of line, and this is called an undefined slope. And the best way I can represent it is this little biker. And as he bikes down an undefined slope, it is undefined what's going to happen to him, right? So those are the four different types of slopes we're going to be working with, and we're going to be calculating them as we go along in the section. So the first thing I wanted to show you was just, I wanted to bring in this idea of rate of change. And why is a slope called a rate of change? Well, it's the rate at which something is changing. And I'm going to show you what that means graphically on the next slide. But let me show you what it looks like on a table of values. So here we have a two table of values. I'm going to look at the first one on the left. And what we want to do is just look at the x values and look at the y values and see how they're increasing. If we first look at my x values, you can see that my first x value, when it increases to the second value, it's just going to be increasing by 1. And then the second to the third is going to also be increasing by 1. And then the third to the fourth, it's actually going to be increasing by 2 this time. And then if I look at my y values, I can see that my first to my second y value is going to be increasing by 5. Second to third is going to be increasing by 5. And then the third to the fourth is going to be increasing by 10. Now, the rate of change is going to be the change over the y over the change over the x. And a little way that I can indicate that is change over the y and change over the x. And that little triangle there, that means change. It's a delta. So if I were to take my y and divide it by x, let's see what we get here. So if I take the change in my y, which is 5, and the change in my x, which is 1, 5 divided by 1 is going to give me 5. So I'm just going to put a little 5 over here. Now let's try the second one. Change in my y divided by the change in my x, that's also going to give me 5. And then the change in my y divided by the change in my x, that's also going to give me 5. So you can see that the rate of change of these coordinates from my the graph are going to be identical. And so this is going to indicate that this is going to create a line that has a constant slope, and which means that the rate of change is going to be the same. I'll show you what that means graphically in just a moment. But let's go ahead and look at another table of values that is not going to have a common rate of change. So let's look at my x values. You can see here on the next table that my x values are going to increase by 1, and then 1 again, and then 1 again. My y values are going to be a little bit different. You can see that they're increasing by 2, by 3, and then by 2. So when I do my change in y over change of x, let's do that. 2 divided by 1 is going to give me a 2. 3 divided by 1 is going to give me 3. and then 2 divided by 1 is going to give me 2. And you can see here that my rate of change with all of these points is not the same. Therefore, this is not going to create a line on my coordinate plane. And I really can't even discuss the concept of slope because it is not a constant rate of change. Now that idea using the table of values is really going to come into play here as we go on. Let's go ahead and look at some graphs. This is where the visual aspect of the concept of slope comes in. So let's just focus on these, the idea of a positive slope. That's when the biker is going from left to right and he's going uphill. And we have this concept called the rise over the run. Rise over run equals slope. You can even write that little note up at the top. The rise over the run is equal to m, which is my slope. Now let me show you what I mean by rise over run. Hopefully you've heard of that little video game Pac-Man. Have you seen this before? Well, rise over run is going to be moving Pac-Man style. Let me show you what I mean. I'm going to locate my 2 coordinate points on my graph, and I'm just going to go ahead and pick one. I usually like to pick the point that's furthest to the left of the graph. So I'm going to go ahead and I'm going to choose this coordinate here. I'm going to see how many spaces it takes me to rise to get to the other coordinate. So in our case, I'm going to rise 1. This is 1 unit. Then I'm going to run to get to the second coordinate. How many spaces did I go there? 3, 4, 5, 6 spaces. So you can see that my rise was 1 and my run was 6. Therefore, the slope of this line is 1/6. Let's go ahead and do another one. I'm going to go ahead and I am going to choose the coordinate. I'm going to choose this coordinate over here to begin with because it doesn't matter what coordinate you begin with. So let's go ahead and rise. I'm going to rise going this direction. Now going downward means that you're going negative. So really I'm going down -2. Then I'm going to run -1. And that's going to give me a rise of -2 and a run of -1, which I know will not only simplify to 2 over 1, making it positive, but it'll also simplify it down to 2. The slope of this line is going to be 2. Now you might be wondering, well, how does that work if I use either point? Well, let me go ahead and change my pen color real quick, and let me show you the other direction. This time I'm going to start with this coordinate. If I rise, I'm going to rise +2, and I'm going to run +1, giving me that rise of 2 and my run of 1, giving me the answer of 2. So no matter what, as long as you do the math correctly, you should have a positive number at the end of this problem because it is a positive slope. You can always check yourself just by looking at the picture, and it's a picture of a positive slope, so the number should be positive as well. Okay. Now, I am going to add one more concept to this. Now, you can see that in this example, I have these 2 points given to me. But there are also other points on the line. And you can see that they're going to be points that also have a rise of 2 and a run of 1. So I have 3 other points that are going to be on this graph right here that have a rise of 2 and a run of 1. And it's actually going to continue on and on and on forever. In opposite directions, continuing that slope of 2. All right, now let's look at some negative slopes. So now we have, let's go ahead and start with this point here. I'm going to start here, and I'm going to try to make it Pac-Man style down to the other point. So I'm going to rise. You can see that my rise is -3, and then my run is +4. See how I'm moving in the positive direction? So my slope is going to be -3/4. -3/4 cannot be simplified, and therefore it's just going to be a slope of -3/4. You can see that the slope, the number itself is negative, and you can see the picture that I have is also a negative slope as well. Those two should match up. Okay, and the last one here. I'm going to start with this point this time. It doesn't matter what point you start with though. I'm going to rise +3. And I'm going to run -3. You can see I'm moving in the negative direction. So that's going to give me 3 over -3, which I know will simplify down to -1. So therefore, the slope of this line is going to be -1. Now you can also see that there are a lot of other points on this line. You can see that the slope of this line is -1, and it's going to go all the way up this page here. Okay, let's look at the other two that we talked about here today. Zero slope. All right, let's talk about zero slope and how that works. Now, if you were to identify this line and you would know right off the top of your head that any horizontal line has a zero slope, then that's awesome. But let's say you forget. Here's how you can use the rise over run to help you. I'm going to go ahead and I'm going to start with this point here on the left. And I'm going to rise 0. And rising 0, just write a 0. And then I'm going to run, in our case it's going to be 4 points. Now you might be just, running to this coordinate here or this coordinate over here, but it doesn't matter. The point is 0 divided by any number is going to give you 0, making this a 0 slope. Okay, and the last one, I'm going to go ahead and I'm just going to pick this point here, and I'm going to rise -2, and I'm going to run 0 because I'm not moving left to right. So my rise is -2 and my run is 0. Now, if you would like, take your graphing calculator out and try to take -2 and divide it by 0. And your calculator is probably going to say something like, error, you can't do that. You cannot divide by 0. You can never do that. Therefore, this is going to be undefined. And I usually like to indicate that by UND, undefined. This is an undefined slope. So the key here to know is when you have 0 in the numerator, you're going to have a 0 slope. If you have 0 in the denominator, you're going to have an undefined slope. All right, now let's go ahead and talk about some ways to calculate the slope or the rate of change. We have this formula, and I do believe this is the second formula of algebra so far. And this is a formula that will be given to you on your formula sheet. So you do not need to commit it to memory, although I think you'll have it down pat after this section. So the formula is m equals y2 minus y1 over x2 minus x1. And what we're going to do is we have to pretend that these two given points are 2 points on a line. We don't even know what the line looks like, and we're not going to take graph paper out to try to plot it. We're just trying to figure out what is the slope between those two lines. Is it positive? Is it negative? Is it undefined? Is it 0? And what is the actual slope numerically? Here's how you do it. Before I even begin to think about my formula, I want to label my points. I know that this first coordinate here consists of an x and a y, and I know that the second one consists of an x and a y. So I'm going to label it x1, y1, and then x2, y2. And you can absolutely flip these around. What I mean by this, I'm going to put it in green, and then I'm going to erase it. But I could also call this guy x2, y2, and then x1, y1. I can absolutely do that. Now, I can't mix up the x's and y's because we always know that the first position is the x and the second is the y. But I can flip the coordinates if I like. Okay, now that we have this set up, I'm going to use my formula to figure out my slope. So if you look at that formula, it should look pretty familiar. It should look like that change in y over the change in x, right? Well, it's exactly what it is. So let's go ahead and solve it out. M is equal to, now the change in my, the y2 minus y1 is going to be -18 minus -3 divided by my change in x2 minus x1. That's going to be 3 minus 2. You can see in the numerator, it could get really hairy there with the minus and the negative. So just remember, part of the formula is the minus sign. So if you have negative numbers, you have to include both of them. Okay, so now what we have here, we have -18 minus -3. That's going to give me -15. My denominator is 3 minus 2, which is going to give me 1. And this is going to simplify down to -15. So therefore, the slope of this line that has these two specific points on it is going to be -15. So basically what that looks like, it's a rise of -15 and it's a run of 1. All right, now if you kind of think about some situations that could occur, Think about this. What happens when your x values are the same? You see in this example, my x values are going to be the same. Isn't that going to give me a situation where my denominator is going to be 0? Because aren't they going to cancel out? Therefore, if you have a denominator of 0, that means that you're going to have something that is going to be undefined. Likewise, if your y values are going to be the same, that means that you're going to have 0 in the numerator. That means that you're going to have a slope of 0. So be on alert for different problems like that with common x values and common y values. It'll be really easy to answer the question. Okay, so that's how you solve a slope or rate of change using 2 points. Now let's do some application. All right, this first question here says, a climber is on a hike, and after 2 hours, he is at an altitude of 400 feet. After 6 hours, he's at an altitude of 700 feet. What is his average rate of change climbing the mountain? So we're trying to figure out what's the rate of change of this climber given 2 locations and 2 time frames that he's been climbing. I like to set problems up like this using 2 coordinates. So I'm going to set up 2 coordinates. The first coordinate is going to be 2 hours and then 400 feet. Now, I knew to place my 2 in the x position because 2 is a time, or 2 hours, that's a time, and that's an independent variable, meaning that it doesn't depend on anything. It's time. So I'm going to go ahead and use that as my x variable. My other coordinate is going to be 6 hours and 700 feet. Now that I have those 2 coordinates and those 2 pieces of information, I can go ahead and use my formula to solve. So I'm going to label this one x1 and this one y1 and this x2, y2. I would highly recommend doing this little labeling. It will really help you prevent errors. All right, my formula, m is equal to y2 minus y1, so those are my y's, over x2 minus x1. Alrighty, and that's going to simplify down to 300 divided by 4. All right, I can take that down even further. I know this is in the form rise over run, but if I can simplify it further, I want to go ahead and do that. So that's going to simplify down to 75. All right, so the answer to this question is going to be, what is the average rate of change? Well, the climber is climbing approximately 75 feet per, that little line means per hour, on average. All right, I have one more example here for you. Let's talk about looking at slopes and proportions. We talked about proportions in the last unit. Now we're going to apply it with this concept. You're going to be seeing a lot of this in Algebra 1, where we're going to be using the previous concepts and the new concepts we're learning about. All right, it says determine the value of y, so the line that passes through negative 2y and 6, 7 has a slope of 1/2. This is a really cool problem. Let me show you why. All right, now that I know this new slope formula, I can go ahead and use it. I'm going to start by labeling my 2 points as such. All right, I'm going to go ahead and write my formula off to the side. Ooh, that's a minus sign. Oops. Now you can see that the slope is equal to this formula. Well, don't they give me a slope? So really, can I say this? 1/2 is equal to, and then do my slope formula. 7 minus y divided by 6 minus negative 2. You can see what it's done now. It's constructed a really nice proportion. So let's go ahead and simplify this. I have 1/2 is equal to, I'm just going to simplify this one little piece. And now I have a proportion. I'm going to go ahead and use my cross products, and I'm going to simplify. That's going to give me 1 times 8 equals 2 times 7 minus y. And I'm going to simplify it just like I know how from the last unit. 8's going to equal 14 minus 2y. And then I'm going to solve this two-step equation as such. Divide both sides by -2. So my y will equal 3. So the answer to this is not indicating what my slope is, because I already knew from the problem that my slope was 1/2. What this is saying is that given these two coordinates, these two coordinates create a line with the slope of 1/2. And I was searching for the y coordinate in this first coordinate pair. So now that I know that, the coordinate -2, 3 and 6, 7 are 2 points that lie on the line that have a slope of 1/2. It's kind of a cool little way to do this. Now, they're not always going to give you this particular letter to look for. Sometimes it'll be in another position and you'll still solve it the same way. Alrighty, so that is going to, that's going to bring us to the end of our concept of slope and rate of change.